All right. So, hi all. A very good evening and welcome back to the 8th week of TA Live sessions for Artificial Intelligence Search Methods for Problem Solving. Um, so first of all, can you hear me properly? Is my voice audible and is the screen visible? Okay, thanks for the confirmation. And yeah, so this week we'll be covering some questions from different planning methods. Uh, we'll take a very simple example and we'll go through methods like uh, we'll first go through what is an optimal plan, um, what is forward state space planning, what is backward state space planning, goal space planning, and partial order planning. We'll briefly go over all of these, and yeah, in the end, so there was one request in the discussion forum that I saw, uh, where someone had requested for an explanation or a solution for one of the SSS star questions from the current assignment. So if we have time remaining towards the end of the session, we'll go through that as well. So yeah, that's the plan for today. Uh, but for now, let's first get started with the questions without any further ado. Yeah, so before moving on to the questions, let me briefly explain the uh, problem setting that we are going to deal with for the questions today. So firstly, we are given a set of predicates. Okay. So let's go through each of these. So what this first predicate at x comma loc means is that a person whose name is x is at a location called loc. Okay. Similarly, this hospital appointment x basically means that this person x has an appointment in a hospital. Again, no jab x basically means that the person X does not have any jab or any dose of the vaccine given to him or her. Okay. One jab means that the person has got one jab or one dose of vaccine, and two jab means that the person X has got two jabs or two doses of vaccine. Now, ticket X comma event means that X, the person X, has a ticket for an event, and that event could be a concert, a flight, or a train. Okay, and the last predicate is attending x comma event, which basically means that x is a part of the event or x is attending that event in simple terms. Okay, so are the predicates clear? Any confusion about what the predicates imply? Okay, that's great if there's no confusion. Now let's move on to the operators. So we saw a couple of predicates. We are also going to deal with some operators that operate on these predicates. So let's have a look at those. Okay, so what these operators do is they have a name. Okay, for example, the first operator, it's called get jab 1, which basically implies that a person X will be receiving his or her first jab or first dose of vaccine. Now, for every operator, there are some preconditions that need to be satisfied that are shown by this pre statement over here. Okay, what this basically means is that in order for us to be able to apply that operator, these preconditions must be satisfied. Okay, you could draw an analogy to something very simple in maths, in mathematics that we do when we perform a divide operation, right? We assume that the denominator is not equal to 0, right? It's a very simple example, so you could draw an analogy to something like that. So we need some preconditions to be satisfied in order for us to be able to apply this operator. And for this particular operator get jab 1, the precondition is that the preconditions are that the person X must not have received any dose of vaccine before or any jab of vaccine before. Only then we can say that okay, now the dose that now the dose of vaccine that the person would be receiving would be his or her first dose. Okay, so that is one precondition. The second precondition is that the person X should have a hospital appointment, and the third precondition should be that the person X should be at the hospital physically. Okay, so here that location is replaced by hospital, if you recall from the predicates. Now, along with the preconditions, each operator will have certain negative effects and certain positive effects. So what we mean by negative and positive effects are, so suppose you are in a particular state, let's say, okay, let's call this state S. How you will define that state is by a number of facts, and that those facts would basically be some instances of the predicates that we saw in the previous slide. Okay, for example, we could have something like no jab Ram. Okay, this basically means that Ram has not received any dose or jab of vaccine. Another fact could be hospital appointment, some other person, let's say Lakshman. Okay, so basically a set of these facts or instances of those predicates would form a given state, and when you apply a certain operator, that operator would result in some of these facts becoming untrue. Okay, so those would be called the negative effects of the operator. For example, if we consider the first operator get jab 1, when a person named X would receive his or her first dose of vaccine, then the fact that the person X has not gotten any dose of vaccine, this would become false, right? So this would be called a negative effect of the operator. Similarly, hospital appointment X would also be a negative effect, because when we apply this operator, basically the person doesn't need to have an hospital appointment anymore. Also, the person doesn't need to be at the hospital anymore. So these would be all the negative effects. Along with the negative effects, there will be some positive effects, which means that some new facts will be added to our state, okay, as a result of the operator. And the positive effect in this case of this operator get jab 1, would be that the person X would now be called to have one dose of vaccine, or basically one jab X. Okay, so was the first operator clear? Okay, that's great. Um, okay, so let's go through all of these operators one by one, just so that we are on the same page. These are pretty straightforward, so I'm confident that all of you will be able to understand it very quickly. But just for the sake of continuity, let's go through each of them one by one. So the second operator is get jab 2x, which basically means that the person X will be receiving his or her second dose of vaccine. The preconditions for this one are that he or she must have one dose of vaccine already, and again hospital appointment, and at the hospital should be satisfied. Negative effects would be one jab X, hospital appointment X, and at hospital X, and positive effects would be two jabs X. Okay, the third operator is get appointment X, which basically means that this operator would allow the person X to get an appointment at the hospital. Okay, and there are no preconditions for this particular operator, which basically means that we can apply this operator at any instant of time in any state. Okay, also it doesn't have any negative effects, it only has a positive effect, which is that the person X, after application of this operator, has an hospital appointment now. Okay, so that was the third operator. And the fourth operator, go X comma hospital, which basically means that now X is going to the hospital, and the precondition would be, one simple precondition is that X should be having an hospital appointment to begin with. The negative effects are again nil, and the positive effect after application of this operator is that the person X will now be at the hospital physically. Okay, so that is the fifth operator, or the fourth operator. The fifth operator is that book X comma event. this basically means that we are booking a ticket. The person X is booking a ticket in order to attend the event. Again, this event could be a concert, a flight, a train, or anything, right? The precondition for attending an event is that the person must have had 2 doses of vaccine only, then he or she can attend the concert or get a ticket for that concert or any event. Negative effects are nothing, and the positive effect after application of this operator is that the person X now has a ticket for the event that he or she wants to go to. Okay, now the last operator is attend X comma event, which basically means that this would allow the person to physically attend the event, and the preconditions being that the person X should have a ticket for the event. The negative effect would be the ticket X comma event, because once the person is actually attending the event, he or she would not require the need for a ticket, and the positive effect would be attending X comma event. Okay, pretty straightforward. So any doubts about the operators that we discussed? Okay, difference between predicate and operator. So predicate, you could say, are generalized versions of facts. Okay, for example, when you talk about a predicate called, let's say, no jab X. So X here could be replaced by any individual, right? Um, Okay, I'll come to the second doubt one after a while. So in predicate, yeah, it's basically a generalized instance of various facts, and an operator is basically something that utilizes different or some of these facts and changes and remove some of these facts, make some of these facts untrue, and then add some extra facts to the current state, and that's how we progress through the different states. Okay, and that constitutes our parts of the plan that we will be forming in different problems that we'll be seeing, uh, maybe through the different algorithms. Okay, predicate is where there can be two options, like not necessarily. So a predicate can take any values. It doesn't have to be restricted to two specific values, right? For example, is no jab X, there X could be taking any value, any uh, any human's name we could put in there, right? Yeah. Okay. So yeah, why are we explaining the previous year's questions? So the reason we are explaining the previous year questions or discussing the previous year's questions is that discussing current year questions would be unfair, right? So, uh, so the point of these live sessions is to kind of expose you to some of the ways or tactics of problem solving. If that helps you in any way, then it will be great. You can utilize these to solve the current assignments, and once the current assignment deadline has been finished or it's over, and if you have something specific that you would like to be discussed in this live session, then you can always raise it in the discussion forum, like one of your friends has done in the past week, and we are going to discuss that towards the end of the live session today. Okay, so I hope that addresses all such queries. Um, okay, now let's get back to our slides. So we discussed the predicates and the operators. Now, yeah, so we are given two things. Okay, we are given one initial state and one goal state. Okay, and what we have to do is we have to construct the optimal plans for each of the three goals or agents. Okay, so the three goals or agents in this case, if you see the goal state, are Aisha, Amol, and Anisa. Okay, so here you see that X has been replaced by Aisha, Amol, and Anisa in three instances, and these three sub goals form a part of a compound goal or a bigger goal that we must satisfy through some planning strategy. Okay, how we will construct that planning strategy, that we'll see in the upcoming algorithms, but since this is a very simple example, you can also try to construct an optimal plan for each of these goals by hand, and you can try to see which of these actually fit well, or how you can achieve the goal state from the given initial state. And we are also given that the three plans are independent and can be executed in parallel to compose the overall plan, right? Because you see the three sub goals have to deal with three distinct individuals, Aisha, Amol, and Anisa, right? So we can make uh, plans for each of these independently and then club them together. Yeah, so that is basically the setting. Any confusion about the initial and goal states? Okay, you got confused with proposition. No worries. That's all right. Uh, uh, if A on B and B on C, uh, okay, okay. While you attempt to try to come up with the optimal plans for each of these three goals, I'll try to address one of the doubts in the chat box, and after this we can have a discussion. Yes, Shashi, we are covering week 8 content. Okay, so you are saying if A is on B and B is on C, then can we say A is on C? No, we can't say. The on operator, if you have defined the on operator in the sense that on operator takes only two arguments over here, then you can't say on A on C because A is not directly on C, right? It's on B on C through B. So if you define your operator in a way that that takes this into consideration, that there can be any number of intermediate blocks also, then you can say yes, on A comma C is also true, but otherwise not. So it basically boils down to how you have defined your operators. And if you're referring to something specific from the lectures, then maybe you can revisit the lecture recordings by Professor Kemani, and he would have thrown some light on these for sure. Okay, so yeah, I'll give you a couple of minutes on while you try to come up with optimal plans, and then we can have a discussion on the solutions. Okay, so a couple of doubts. Let me go through them one by one. Um, so Ali, can you explain the session with blocks concept examples? So, since we already have one examples problem setting that we are dealing with, which is this getting jabs of vaccines and attending events example, let's go ahead with that for the time being. And if there is some specific thing that you would like me to discuss, maybe towards the end of the session or in the upcoming session next week, let me know through the discussion forum. And even if you understand just any one of these examples, you understand how to apply the algorithms, you won't face a problem, be it this block setting or this vaccine and event setting. Okay, so it's just about learning how to apply the different methods. The problem setting should not be an issue. Okay. Yes, Vanshika, we will go through forward state space planning and backward state space planning in some of the upcoming questions. But for now, you can try to construct the optimal plans by hand, and then we'll have a look at these two methods. Can you post the current notes in PDF? So, if you're talking about the lecture notes or the lecture slides, they I think would be available in the lecture notes section. Um, if you're referring to the question and answers that we are discussing in the live session over here, so the presentation slides for the question answers for the live session have already been uploaded in the drive folder where they are usually available, and the Jamboard, if you want, I can upload it after this session ends. And yeah, the video I'll try to getting it uploaded on YouTube by tomorrow. So I hope that addresses your query, Akshita. And yeah, thanks for your answer also, Pranav. So Pranav has given one answer. Um, what do the others think? Okay, maybe we'll wait for 2 more minutes and then we'll discuss the solutions. Okay, so I see a couple of you have given solutions, and that's great. Um, let's now discuss the solutions and see which of these are correct. Okay, so let's consider these subgoals one by one. Okay, let's consider a mole first. Okay, so in order for us to achieve this particular uh, predicate, attending a mole comma concert, let's look at which operator could give us this predicate. Okay, and that happens to be um, attend x comma event. Okay, so we would need to have something like attend a mole comma event in order for us to have this as a positive effect, attending a mole comma event. Now, in order to be able to apply this operator, attend a mole comma event, we have a precondition that needs to be satisfied, and that is ticket x comma event or ticket a mole comma event, right? And how can we achieve that? In order to achieve that, we have to apply this operator, right? Because the positive effect of this book x comma event is ticket x comma event, and the preconditions for this book x comma event is that x must have 2 jabs or a mole must have 2 jabs. So let's have a look whether, as per our initial state that is given to us over here, is 2 jabs a mole satisfied? Yes. So we are already given that a mole has 2 jabs of vaccine, so we can directly apply the book a mole comma event operator, and as a result of that, we would have this fact added to our state, which is ticket x comma event or ticket a mole comma event. Okay, so basically our state would become like this. Ticket a mole comma concert. Okay. Now that we have ticket a mole comma concert in our state, we can say that this precondition is satisfied, and we can apply this attend a mole comma concert operator as well. And once we apply that, we will arrive at this sub goal that we wanted to achieve of attending a mole comma concert, right? So as some of you pointed out in the chat box, the optimal plan for a mole would be to use these two operators to first book the ticket for the concert and then go on to attend that concert. Okay, so it will have only 2 steps. A mole will have only 2 steps in his plan. Okay, now let's consider Anisa. Yeah, so again, in order for Anisa to attend a concert, she must have a ticket to the concert, right? And in order to get a ticket to the concert, she must have 2 jabs of vaccine. So as per the information in the initial state, does Anisa have 2 jabs of vaccine? No, we are told that Anisa has only 1 jab of vaccine. So first we will have to make Anisa take another jab of vaccine. Okay, so how do we do that? In order to do that, first we will have to get an appointment, right? Because without getting appointment, you can't go to the hospital. So the first step in the plan for Anisa would be to get an appointment to the hospital. Okay, so get appointment, Anisa. Sorry for the horrible handwriting, but I hope you will get it. Yeah, so again, so this does not have any precondition or negative effects. It will simply add this fact to the state, which is Anisa now has the hospital appointment for some hospital. And once that is satisfied, once that is added to the state, we can apply this operator, which is Anisa now goes to the hospital. So go Anisa, hospital. This would be the second step in her plan. And once this operator has been applied, this at x comma hospital would become true. Okay, so once this becomes true, we can apply this get jab to operator because all the preconditions would now be satisfied. We are already told in the initial state that Anisa had a shot of vaccine, so this is already satisfied. Because of the application of our get appointment operator in the first step, this hospital appointment X is also satisfied. And as a result of application of this go Anisa comma hospital in the second step, this at X comma hospital is also satisfied for Anisa. So all the preconditions are satisfied for this getJab2 operator. So we will apply that in the third step, getJab2 Anisa. Okay, this will be the third step, and as a result of this, all this one jab x, hospital appointment x, and add x comma hospital would be removed. So this x will be replaced by Anisa in this case because we are dealing with Anisa's goals. And this 2 jabs x is going to be added to our state. Okay, or 2 jabs Anisa will be now added to the state. So now that 2 jabs Anisa has been added to our state, we can now apply this book operator. Okay, so that will be the fourth step. Book, Anisa, and concert. Okay, so as a result of this operator, now Anisa will have a ticket for the event or the concert, and this will be added to the state. And because this will be added, we can now use this attend operator, which will be the final step in her plan. And once once this operator is applied, now this attending Anisa comma concert would be true. Okay, so there will be 5 steps in Anisa's plan: get appointment, go, get jab2, book, and attend. Okay, any doubts about Amol and Anisa's plan as of now? Okay, that's great. Okay, so Pranav has also given the plan for Aisha, and that's great. Um, okay, let's quickly have a look at Aisha's plan as well. Let's remove all this. Okay, so now we are considering um, Aisha's goal, which is to attend the concert again. And let's keep in mind what is the information given to us about Aisha in the initial state. We are told that Aisha has no shot of vaccine. Aisha has an hospital appointment, and Aisha is also at the hospital physically. Okay, so it seems like Aisha is just a bit behind Anisa in terms of her plan. So Anisa already had one jab to begin with, while Aisha doesn't have any sort of vaccine. But the good thing is that Aisha already has a hospital appointment and she already is at the hospital. So for Aisha, we can directly apply the get jab one operator because all these preconditions are satisfied. Okay, so there will be just one additional step in the plan for Aisha, which would be to get jab one before all the steps that Anisa took. Okay, so there will be 6 steps in the plan for Aisha. Okay, any doubts about the optimal plan? So I'll do one thing. I'll show you the optimal plans that I have written, and you can convince yourselves about the validity of each of these. Remember that as we apply different operators, there will be some negative effects and some positive effects, and because of these negative and positive effects, the number of facts in our states will change dynamically. Okay, so we need to take account for that when we are trying to apply different operators at different steps. Okay, so I'll give you a couple of minutes and then we can move on to the next few questions. Okay, so Rocky is asking, doesn't get appointment come first? So in whose plan are you asking about this? In Aisha's plan, do you mean? So get appointment doesn't have to come first because we are already told in the initial state that Aisha already has an appointment, right? And remember, you are asked to construct an optimal plan. What this optimal plan basically means is that you want to take as less number of steps as you can and achieve your goal still. Okay, so while you still could apply the get hospital appointment operator, it would be redundant because you're already given the information in the initial state that Aisha has the hospital appointment. Okay, so the optimal plan would not contain the get appointment step in the first step basically. Does that address your query? Okay, that's great. Yeah, so a couple of queries in the chat box. Let me address them one by one. So, Sashi, if the confusion from the last week assignment that you're having is regarding the SSS star method, we are going to discuss that towards the end of the live session. If it's something else, maybe let's wait for the questions for this week to get over, and then we can think about it. Otherwise, we can always discuss it in the next live session. So keep me posted about it. Um, yeah, we'll go over Aisha's plan one more time. And yeah, so basically Aisha is in hospital. So why should she get another appointment and go to hospital? Yeah, exactly. That is the point. That is the reason why we're calling it an optimal plan. Yes, an optimal plan will have as less number of steps as we possibly can have. Okay, so let's quickly go over Aisha's plan one last time. So basically, in the initial state, um, we are told that Aisha does not have any sort of vaccine. Aisha has an hospital appointment and Aisha is already at the hospital. Okay, so these three facts are given to us about Aisha. What we can do is we can see how we can utilize these three facts to arrive at our goal. And because we are given these three facts already, we can directly apply this first operator get jab 1. Okay, because all the preconditions that need to be met for us to be able to apply this operator are already given to us in the initial state. So we will directly apply this get jab 1 operator, and the result of that would be the removal of each of these from the states. This will be removed, this will be removed, and this will be removed, and one jab Aisha will be added. One jab Aisha. Okay. Uh, Again, sorry for the terrible handwriting, but yeah, I hope you can get the point. Okay, now that one jab Aisha has been applied, and now since these facts have been removed from our state, for Aisha to get the second jab of vaccine, now she will have to get an appointment from the beginning. Okay, so we'll have to add these to our state once more. So then again, Aisha will have to do a get appointment to get an hospital appointment. She will have to use the go operator to go to the hospital physically, and then she will have to use the get jab 2 operator to get the second dose of vaccine, and then two jabs Aisha will be added to the state, and these will be one jab X hospital appointment X and at X comma hospital where X is Aisha. These will be removed from the state. Okay. So basically those three constitute the first three steps of the plan for Aisha, which is to get jab 1, Then she has to get an appointment to get the second dose of vaccine. Then she has to go to the hospital to get the second dose of vaccine, and then she has to uh, get the second dose of vaccine. That will be the fourth step. And once she has gotten the second dose of vaccine, then she can use the book operator to book her ticket for the concert, which is the fifth step. And the sixth step is to use the attend operator to attend the concert. Uh, so you don't need to concern yourselves with whether these plans are applicable on the same day or different days, unless that is given as a predicate to you. In this problem setting, we are not told to worry about the day, so you need not worry about that. Okay, you can simply form the plan as per the predicates and operators given to you. And yes, Sashi, we will discuss this in a later session or in this session even if we have time remaining towards the end. Okay, so any more doubts on this particular question? Okay, so your question is that why is she getting appointment again if she is already in it? Okay, so this is something that you will get more familiar with if you have come across the counterpart to this course, which is the knowledge representation and reasoning course, or even if you have not come across that, if you will stay with this course maybe till week 11 or 12, you will get a feel of that particular course. And the reason I'm mentioning that course is that uh, so many a times in these kind of settings, in logic based settings, we only have to deal with the kind of the information that we have been given. Okay, we cannot assume anything more and anything less. Okay, so since we are not given any information about the timestamps of the day, we cannot deduce that even after Aisha has gotten the first dose of vaccine, she's still at the hospital. Okay, because immediately after we apply the get jab 1 operator, that results in one jab Aisha getting added to the state, but it also results in uh, hospital appointment Aisha and at Aisha comma hospital being removed from the state. Okay, so the AI machine that you have, that will not know that whether Aisha got the dose of vaccine on the same day or whether she's still at the hospital. Okay, that's why you have to again apply for an hospital appointment using the corresponding operator and again use the go operator to go to the hospital. Okay, so I hope that addresses your query, and I saw a couple of more responses in the chat box in the meanwhile. Let me just go through them. Yes, the appointment predicate is cut after jab 1. That is right. Uh, yes, she's getting appointment again because it's for the second dose. Two doses, yeah, for every dose she needs another appointment because that is how we have defined the operators. The condition does not say that she cannot get two jabs at a time. That's exactly why we cannot assume that she can get two jabs at a time. Right? Since we are not given that information, we only have to limit ourselves to the information that we are given. Okay, we have to restrict ourselves to the preconditions, the positive effects and the negative effects of each operator. So I hope that addresses all your queries. Okay, okay, so I'm assuming that there are no further queries about this particular question. Okay, that's great. So let's quickly have a look at presentation slides and see what were the questions that we were basing on this optimal plans that we just constructed. And yeah, so the first question was, which agent has the shortest optimal plan? So what do you think will be the answer to this one? Amol. That is correct because we just saw that Amol had only two steps in his plan, whereas Anisa had 5 steps, and Aisha had 6 steps. So yeah, Amol has the shortest optimal plan. Straightforward. Let's look at the second question. What is the length of the above agent's optimal plan? This is again 2, like we just discussed. Okay, let's have a look at the third question. Which agent has the longest optimal plan? Yes, that would be Aisha. So option A is correct. And the fourth question is, what is the length of the above agent's optimal plan? That would be 6, like we just saw. Okay. Yeah. Okay. Now we come to one of the methods that we are going to, formal methods that we are going to see for planning, and that is forward state space planning. So let me just give a brief overview of what we mean by forward state space planning. Okay. Okay. So assume you are given some initial state. Okay, like we are given in this particular problem. Okay, now based on whatever initial state that you are given and whatever the facts are given are a part of this initial state, there will be different kinds of operators that you could apply in this initial state. Okay, they may or may not be part of an optimal plan. Okay, what I'm trying to say is, using different combinations of the facts that are given to you in the initial state, you could apply a number of different operators. Okay, and some of which might actually be redundant even for your optimal plan, but still you could still apply them nevertheless. Okay, for some non-optimal plan, let's say. So you will draw a tree structure where the children of this initial state would be all the different operators that you could apply. Okay, so let me mark them with a circle. Okay, so let's say this is 5 different operators that you could apply in your given initial state. Now, as a result of application of this operator, let's say the first one is called operator 1, there will be some changes to the state, right? Because there will, some of the negative effects of this operator will be removed and some positive effects would be added. Let's call this state S prime. And again, based on the facts that are present in this S prime state, again you could apply different number of operators. Okay, and you could do this for all of these operators in the first level of the tree. Okay, and if you go on doing this, your tree will keep on expanding until you arrive at a state where all your goal conditions or all your goal predicates have been met or satisfied. Okay, so this is basically how forward state space planning proceeds. It starts with the initial state. We look at what are the applicable operators or actions, and then we further see what are the resulting states after application of each of these, and then we again see what are the operators that could be applicable, and then we proceed so on and so forth. And that is one shortcoming of the forward state space planning method, is that uh, the number of branches of each of the nodes in this tree starts increasing exponentially as you move down the tree. Okay, because as you move down, there will be more and more branches, more and more children getting added to each node, and that will result in an exponential increase in the number of branches. Okay, and so that is not computationally very efficient as we move further down along the tree. But that is the basic idea of the forward state space planning method. And so given that idea of forward state space planning, which of the following do you think could be the first operator that can be considered by Aisha for her plan? Okay, so remember the keyword here is considered, not applied in the optimal plan. Okay, so based on that, you can have a look at the options and then see which of them could be the answer or answers in this case. Um, I'll give you a couple of minutes and then we can have a look at the solution. Okay, so yeah, a number of you have given the solutions in the chat box, and that's great. But before going to have a look at the solution, there are a few things that in the chat box that I'll just quickly address. What is a valid plan for FSSP? So I'm not sure if valid plan is a technical term that you're referring to. If it is, then I would recommend you revisit the lecture videos and other lecture slides, and they would have some definition. But based on intuition, so any of these plans that we form using FSSP could be a valid plan, but whether it is an optimal plan or not, that we have to see based on whether it is having any redundant operators in as a part of its plan, right? If it has some redundant operators as a part of its plan that is unnecessarily increasing the length of the plan, then that would not be called an optimal plan. Okay. And couldn't get why it is said that move gen and search strategy are unspecified in FSSP. Again, I'm not sure whether these are some technical things, but if they are, please revisit the lecture slides and recordings. But again, based on intuition, what I could say is that so in FSSP we have a number of options to choose from, right? Um, Yeah, exactly. So Pranav answered what I was also thinking about, and yeah, exactly. So he put it in a more precise manner. It refers to the exact definition. Like MoveGen gives next possible neighbors, but here we don't have any such fixed definition. Right? There are a plethora of options that we could choose from given an initial state, and then we move on to the next state, right? We have to look at the overall optimal plan, not a step-by-step method. So that's why I think move gen and search strategy are not exactly applicable over here. Um, yeah, I think that's about it. Okay, so now let's have a look at the uh, yeah, rightly pointed out by Rocky as well in the chat box. So yeah, thumbs up to both of you, um, and also to Namita for raising this question. It's a good question. Um, okay, so let's have a look at the solution for this one. So which of the following could be the first operator considered by Aisha? For that, let's have a look at what is the information about Aisha that is given to us in the initial state. So we are given these three conditions that we have been talking about since a long time, which is no jab Aisha, at Aisha, hospital, and hospital appointment Aisha. Okay, so these are the three facts that are given to us, and let's see with these three facts what are the operators that we could apply. Okay, so once again, let me clear up this clutter. Okay, so let's have a look at all these operators one by one, um, which is just for the sake of thoroughness, but yeah, you might find some shorter ways as well to arrive at the answer. But anyway. Yeah, so the first operator, get jab 1, requires no jab Aisha, hospital appointment Aisha, and at Aisha, hospital for us to be able to apply it. And we see that all of these three are present in our initial state, so we can apply this get jab 1 operator, or get jab 1 Aisha is something that we could apply. Let's have a look at the second operator, get jab 2. This one of the preconditions for this one is that one jab Aisha must be there, but we don't have that in the initial state. Okay, we only have no jab Aisha, so we cannot apply get jab 2 operator. Now let's look at get appointment operator. This does not have any preconditions, so we can always apply it. Okay, so this is something we could apply. Remove the smaller tick marks. Okay, now go X comma hospital, go Aisha comma hospital. This has one precondition, which is hospital appointment X or hospital appointment Aisha. And we know that hospital appointment Aisha is given as one of the facts in the initial state. So we can apply go Aisha comma hospital. And again, we cannot apply book Aisha comma event because we are not given two jabs Aisha. So this is something we cannot apply. And because we cannot apply this, we also cannot apply attend Aisha comma event. Okay, so the three operators we can apply is get jab 1, get appointment, and go to the hospital in the first step of forward state space planning. Okay, so let's have a look at the options available to us. So A would be one correct answer, C would be one correct answer, and D would be another correct answer. Okay. Okay, so I'll explain once more. So basically what we want in forward state space planning is that given the facts uh, in our initial state, okay, given different combinations of those facts, we need not consider all facts together. We can consider some subset of those facts as also. Given different combinations of those facts that are given in the state to us, which in our case is the initial state in as per this question, uh, what are the different operators whose preconditions are satisfied by the presence of those different facts or combinations of facts that are given in our initial state, right? And as per that, we see that there are three operators whose preconditions are satisfied. One is get jab one is get appointment, another one is go. Okay, so given the three facts about Aisha in the initial state, Aisha could either use the get jab operator to get the first dose of vaccine, or she could get an appointment at the hospital. Okay, again, this would be a redundant action on her part, right? It wouldn't make sense for her to get an appointment when she already has an appointment. But since uh, the preconditions for that operators are still being satisfied, and the AI machine that is applying this planning mechanism that is not as intelligent as us humans, it would not think that much. It will just see that the preconditions are satisfied. Okay, so this is one more candidate operator that Aisha could consider. Okay, that is the point of having get appointment and go also as something uh, that Aisha could consider as the first operator while forming her plan. Okay, does that address your doubt, Rocky? Okay, any other doubts about this question? Okay, that's great. Then let's move on to the next question, which is question 6, which asks us the same thing but for Amol now. Okay, so which of the following are the could be the first operator that can be considered by Amol while devising his plan using the forward state space planning method? And similarly, you can also work this out for Anisa, which would be the next question. And the options remain the same. Just replace Amol with Anisa. And yeah, I'll give you a couple of minutes for solving it for both Amol and Anisa, and then we can have a discussion on the solutions for both of those. Okay, so a couple of queries in the chat box. Yes, it refers to the applicable actions. Yeah, correct about that. Okay, rest of them are potential answers. So yeah, I'll wait for some more time before discussing those. Okay, so now let's have a look at the solution. So for a mole, let's first see what are the initial conditions, initial facts given to us in the initial state. Let us remove this first. Alright, so about Amol, we are only given one little fact, which is 2 jabs Amol. Okay, so let's now have a look at the operators, and again let us remove all of these. Okay, so let's go through each of these operators one by one. Okay, so for get jab 1, the preconditions are that we must have no jab Amol, hospital appointment Amol, and at Amol, hospital, none of which are given to us. So we cannot apply get jab 1. Similarly, we cannot apply get jab 2 because one jab Amol and hospital appointment Amol and at Amol, hospital is not given to us. Now, get appointment Amol is something that we can apply because it does not have any preconditions, right? So this is something we could apply. We cannot apply co Amol, hospital because hospital appointment X is not given to us. Book Amol, event is something we can apply because 2 jabs Amol are given to us, right? In the preconditions of this particular operator, and again this we cannot apply because ticket X, event or ticket Amol, event is not given to us. So for Amol, get appointment Amol and book Amol, concert would be the 2 applicable answers in this case. So let's have a look. Get appointment Amol and book Amol, concert are the 2 correct answers, which is C and E. So that is the answer for Amol. Let's have a look at Anisa next. So again, let's go back to our initial state. Let's look at the information given to us about Anisa. So we are told that Anisa has 1 jab of vaccine and no other information is given to us about Anisa. Okay, so based on this one information, let's have a look at which operators are applicable in this case. Okay, so get jab 1 is not applicable because no jab Anisa, hospital appointment Anisa and at Anisa, hospital is given to us. Get jab 2 is also not applicable because although we are given 1 jab Anisa, we are not given hospital appointment Anisa or at Anisa, hospital, right? So only one of the preconditions is satisfied, only this one. These 2 are not satisfied. So we cannot apply get jab 2 Anisa as well. This again we can apply because this does not require any precondition. This we cannot apply, this we cannot apply, and this we cannot apply because none of their preconditions are satisfied in the initial state. So for Anisa, the only correct option would be get appointment Anisa, okay, which is option C. So I hope it's clear now. Um, any other confusion about the answers for Amol and Anisa? Okay, that's great then. So okay, so there's one question in the chat box for Aisha. Why don't we consider the conditions with and? So we do, right? When we are trying to apply the get jab 1 Aisha operator, we do use all the 3 initial conditions that are given to us, right? Were you referring to that, or can you elaborate a bit more on what exactly your doubt was? Why Go Aisha Hospital should be applicable? Okay, so Go Aisha Hospital should be applicable because we were given in the initial condition this particular fact: hospital appointment, comma Aisha, hospital appointment of Aisha. This one basically. Okay, this one was given to us, and this is the only precondition that needs to be satisfied for us to be able to apply this go operator. That's why we can apply this in the case of Aisha. Okay. Yeah, again, circling back to the same argument that I was giving earlier, that we know that Aisha is already at the hospital, but the AI machine that is solving it does not consider those facts, right? It will just simply see for which of these operators the preconditions are matched or not. If the precondition is matched, the machine will say that, okay, this is one potential candidate operator that you could apply. Okay, so that is why that is also uh, that means it is seeing or. You mean to, you were referring to the different operators it could apply while forming the forward state space planning search tree. Okay, yeah, that is one of the operators. Obviously, you have to choose one of these operators as you move down the FSSP tree, basically. Yeah, you are correct about that. Uh, yeah, so Pranav, we saw applicable actions just now. So given an initial state, uh, the operators or the actions that we can apply using different combinations of those conditions or those facts given in that state, those will be the applicable actions. What are relevant actions we'll see just now when we will discuss the backward state space planning algorithm. Okay, I hope that will address your question. Um, So Abhishek, you had requested for the answer to Amol. So Amol had only one fact in the initial state given to us. That was that Amol has two jabs of vaccines. Okay, and if you have a look at the operators, so this book operator is one that we can apply because it has the precondition satisfied, and this get appointment operator we can apply because it does not require any preconditions, and none of the other operators have all preconditions satisfied for a mole, right? So these are the only two operators that we can apply for a mole. So I hope that addresses your query about a mole, and yeah. Okay, now let's move on to the next set of algorithm. But what purpose will it solve? So the uh, so we are not here. So the question basically asks us which are the possible. Um, it will not necessarily solve a purpose, right? So we are in the question basically asks us that what are the operators that could be applied as the first operator in the plan for a mole, right? That doesn't mean that we are going to select one of those to be part of our optimal or applicable plan, right? We are just exploring the options and we are just exploring the first set of operators that we could apply, right? That's why we are not seeing whether that is serving a purpose in the long run. Okay. And if you're asking specifically about what will be the effect of get appointment, that will simply be X getting an appointment to the hospital, which is the positive effect of that operator. Okay. Um, does that address your query, Abhishek? Okay. Yeah, you can take time to convince yourself about it. Um, in the meanwhile, let's move on to the next few questions. Let me remove all this. Okay, so now we are going to have a look at the backward state space planning method. So in the forward state space planning method, um, in the forward state space planning method, we started with the initial state, right? But we saw that that resulted in a number of problems, one of them being the high branch factor and the number of branches growing exponentially in the tree, right? So one potential solution to that is to start from the set of goals that are given to us. Okay, so let's have a look at the goals that are given to us. There are three goals or sub goals given to us. Okay, um, and again, these three are independent, so we can try to solve them independently or parallelly. But let's consider them one at a time. Okay, so let's consider this second sub goal of a mole first, because we know already from our optimal plan that this has the shortest plan. Okay, so we will start from the bottom this time. Okay, and so attending Amol comma concert, this will be the goal that we want to satisfy. Now relevant actions would be all those actions that or all those operators that would result in this particular statement being true. Okay, so for example, what are the operators that would result in attending x comma event being true? It's this operator, right? Attend a mole comma event. If it was applicable, then we would say that as a positive effect of this operator, attending x comma event would become true. So a relevant action in this case would be attend a mole comma concert. Okay, so this is a relevant action or a relevant operator. Now this relevant operator had some preconditions, right? What was the precondition for this operator? That x must have a ticket, okay, to the event. Now this precondition will become the goal that we need to satisfy, the intermediate goal that we need to satisfy. Okay, so ticket Amol comma concert is now becomes the goal that we need to satisfy. And again we need to look for what will be the relevant action for this particular goal. So what will be the relevant action for this one? The relevant action would be this book action, right? Because this results in this ticket uh, positive effect. So book will be the relevant action. Book a mole comma concert, and the precondition of book operator will now become the goal that we need to satisfy, and that will be 2 jabs a mole. Okay, so let's add that. So two jabs a mole now becomes the goal that we need to satisfy. But if you observe, this is already given to us in the initial state, right? So we have already reached the initial state or part of the initial state that is relevant for Amol's plan. Okay, so this is how we have constructed the plan in a backward manner starting from the goal, and that is why we call it backward state space planning. We could do a similar thing for Aisha and Anisa as well. We could start from the sub goal for an Aisha or Anisa, which is attending the concert. Then we will look at what is the relevant action. Then the preconditions of that relevant action will become the goals that we need to satisfy. Again, we'll look at the relevant action and so on and so forth until we reach the initial state. Okay, but one problem that we might encounter in using the backward state space planning method is that uh, when we uh, when we are moving in this direction from bottom to up, all is well and good. But once we try to move in this direction from the initial state to the bottom state, we might see that the plan that we have encountered is an invalid plan. Okay, why that may be so? Because when you are considering relevant actions, right, you're not taking an account for the negative effects. Okay, so there might be cases where there is some relevant action, but actually in the forward flow of uh, operators in the plan from the initial state, some of the preconditions for uh, that particular operator to be applicable are not present because of the uh, deletion of some facts due to the negative effects or addition of some facts due to the positive effects, right? So you might end up with an invalid plan. That is one shortcoming of backward state space planning, but one of the positives of this method is that it drastically reduces the branching factor that we were concerned about in forward state space planning. Huh. What if there are two sub-goals for a single goal? Then you try to satisfy both of them. You try to find an operator that satisfies both of them. Or if they can be solved independently, you try to solve them parallelly. Okay. There are not two attend concepts for a mole. One of them is attend, which is the operator. One of them is the predicate, which is attending. Okay. Uh, I hope that addresses your query, Mohan. And I also, the discussion addresses your query, Vanshika, about relevant actions. Okay, so this is the intuition behind backward state space planning, and now let's have a look at the question. So using backward state space planning, which of the following could be the first operator considered by Aisha? Similar question as the just like the last few questions we saw, but just that here we are dealing with backward state space planning, and here we have to look for relevant actions rather than applicable actions, given the goal state that we are trying to reach. Okay, so
Yeah.
okay, some of you have already given the solution, and let's have a look. Yeah, the first operator that could be considered by Aisha is attend Aisha, concerts. That's correct. Okay, so that was an example of backward state space planning. Okay, now, yeah, so I encourage you to solve this completely for Aisha and Amol and Anisa. That would give you a good practice. But now we'll move on to another method, which is goal stack planning, which is, so we saw some, uh, okay, let me just read this message in the chat box. The last state would be the first from the initial state, right? The last state would basically be either the initial state or some part of initial state that is relevant to that sub goal that you are that sub goal that you're trying to find a plan for. Okay, so yeah, coming back to goal stack planning, so we saw that forward state space planning had some positives and some shortcomings. Backward state space planning had some positives and some shortcomings. So goal stack planning is something that tries to take the best of both worlds and tries to form a method that utilizes or capitalizes on the positives of both these methods that we just saw. Okay, so what we do here basically in goal stack planning is that we have a stack, okay, and we we have a look at the goals that we have to satisfy. Okay, so here we have three goals that we have to satisfy. Okay, and all three of them can be independent, are independent, and can be planned for in parallel. Okay, so let's call this compound goal to be G, that is made up of three sub goals, G1, G2, and G3. Okay, where let's say G1 stands for Aisha, G2 stands for Amol, and G3 stands for Anisa. Okay, what we will do in the stack is we will first insert this compound goal G, and then we will insert these sub goals small g1, small g2, and small g3 in some particular order. Okay, then whichever of these small g sub goals is at the top of the stack, we will try to solve that using the uh, by seeing which of the following which of the relevant actions that could have generated that particular sub goal. Okay, and we'll keep doing that until that particular goal is satisfied, and then once we have found that a plan for that sub goal, we'll pop everything out, and then we'll try to solve it for the next sub goal. Okay, and we'll proceed in that particular manner. So if you see, it's also taking the good aspects of backward state space planning and also taking the good aspects of the forward state space planning method. Okay, but we are not going to solve the whole problem using goal stack planning for this particular question. What this goal stack planning question asks is that which of the following options could be the first sub goal considered by the bot. Okay, so the question only says goal, but you can say that which of the following could be the first sub goal considered by the bot trying to solve your method using goal stack planning, solve your problem using goal stack planning. Okay, so basically you are asked about the order of the three subgoals that you will put into your stack. Okay, so I see a couple of you have already answered the question, and most of you are correct, and that's great. Yeah, the answer would be all A, B, and C, because all three subgoals that we want to uh, reach or find a plan for, they are independent of each other because they deal with three different individuals. We can input them in the stack in any particular order. It could be G1, G2, G3, it could be G3, G2, G1, or G2, G3, G1, whatever. Okay, so any of these could be the first goal that is considered by the bot. All right. Any doubts about this solution? Okay, that's great. So now let's move on to. Okay, there's one more question about goal stack planning. Ah, so assuming that the AI bot is planning for the actions for all three agents using goal stack planning, okay, which of the following could be the first action added to the plan by the bot? Okay, so yeah, so we won't give too much time to this one. So let's consider each of them one at a time. So if Aisha's goal was the first one that we had to solve, then get jab one Aisha would be the first goal the first action that would be applicable, uh, given all the uh, okay, so maybe I made a mistake where I mentioned that relevant actions will get added to the stack. It's probably the applicable action, so my bad. Sorry about that. But yeah, anyway, the logic still remains that you will take one subgoal at a time and then add the actions and the further subgoals, further subgoals to the stack. So if it was Aisha's subgoal that you want to satisfy, then the first action could be get jab one. If it was Amol's subgoal, the first action that could be added to the uh, plan would be book uh, book tickets for that concert, and if it was Anisa, it could be get appointment. Okay. How to differentiate between goal and action? So an action would be an operator, right? And goal would be some set of predicates. That's how you can differentiate. Uh, so Vanshika, it will be difficult to come up with a whole block problem setting right at this moment, right? So I hope you have understood this particular problem, and if you have understood that, application to the word block problem should not be an issue. So try it out first by yourself, and if there is a problem that is still there, we can discuss it maybe in the next live session, or if in the session if we have time. Yeah, Abhishek, we are arriving at causal link in the next method that we are going to discuss. Okay, so we are done with goal stack planning. Now let's move on to the next method that we are going to discuss, which is partial order planning. Okay, so again, I'll give you a small intuition about what partial order planning is. And although something that I must mention is that whatever I'm discussing over here about the different methods is simply an intuition about the method, right? So if you want a detailed explanation, it's highly recommended to go and visit the lecture recordings and the lecture slides. Okay, that will help you get the problems or the algorithms clearer much in a much better way. Okay. Anyway, so coming back to partial order planning. So till now we were looking at different steps in the plan that we could add. Now what we are going to look at are partial plans themselves, not individual steps. Okay. So let me use a new page on the Jamboard. Okay. So here we will have one state called A0. Okay. That would require as preconditions nothing. Okay. Nil. And we will assume that the result of this particular uh, state are the different facts given in the initial state that was given to us. Okay, so for example, no jab Aisha would be one of these things, two jabs Amol would be one of these things, so on and so forth. The different facts in the initial state that were given to us would basically form a part of these particular nodes. Similarly, we will have one thing called A infinity that would have nothing as its effects. Yeah, can you maybe mute yourself if you don't have a question? Yeah, thanks for that. Okay, yeah. And these will have incoming edges from the three goals that we want to satisfy or reach. So in our case, it would be attending Aisha comma concert, attending Amol comma concert, and attending Anisa comma concert. Okay, and we have to find again different actions that we could uh, link to these particular predicates. Okay, and then we can expand the tree and fill in this whole structure uh, by uh, forming branches from this side as well. uh, yeah, and we could fill up this whole tree by finding out different relevant actions, and their preconditions could become subgoals and so on and so forth. But there is one aspect that we uh, need to be concerned about in this case, and okay, before going to that, I'll tell you one term, which is open goals. Okay, so an open goal would be any goal which does not have any causal link coming into it. Now what would be a causal link? So if suppose we had some action over here, okay, and this action had a link to this particular goal, which meant that there we know of some action that can result in this sub goal or this goal as a positive effect of that action, then we will call this link as the causal link. Okay, and once any goal node has this causal link, that will be not a part of the open goal. Okay, so open goals would be all those nodes that do not have any causal link incoming into them. So one of the objectives of this method is also to look at different causal links, connect them, and while also take care of threats. Okay, so there might be some partial plans that contradict each other. So in those cases, we will have to find a way out to overcome those threats or contradictions. Okay, but anyway, we are not getting into the details of the method. The details, for the details, you can have a look at the lecture recording. Let's go back to the question that we had, which was, assume that our AI bot is planning the actions for all the three agents using partial order planning. Based on that, which of the following could be the first open goals to be resolved by the bot? So remember, the first open goals we have to think about. So these would basically be the sub goals that we want to satisfy, right? So which of these options do you think would be correct? That's right. So attending Aisha concert, attending Amol concert, and attending Anisa concert would be the three uh, first open goals that can be resolved by the bot. Okay, I hope that addresses any concerns about this question. So the reason DEF will not be the first open goals is that we're talking about the very first open goals, right? So for that we need to have our the predicates in the goal state itself, right? Those will be the first goals that need to be resolved by the bot, not the two jabs goal, which will come later in the graph. Okay. All right. So I encourage you to try to fill up the whole partial order planning graph by yourself. That will give you a good practice. And yeah, that brings us to an end of the questions for today. Um, okay. No, so goal and open goal are not the same. Goal can be any goal, even with a causal link. Open goals are those that do not have a causal link. A0 and A infinity is the same for every problem, but what they have as outgoing and incoming edges depends on the initial state and the final and the first set of goals that the bot might satisfy. Yes, we'll discuss the SSS problem now. And Pranav, so just to address your query about causal link once more. So basically, if you have a set of goals, right? And if you have or if you know of a relevant action that could be a resulting factor for that open goal being satisfied, okay, through your process of constructing the graph, then you will form a link between that relevant action and that goal, and that would be a causal link for that particular goal to be achieved. Okay, so that is basically what is meant by causal link. It is that action is causing that goal to happen or that predicate to happen. A0 and infinity is just a naming convention. A0 refers to the very first node that is resulting in your initial state, and A infinity is the final node uh, that is following your goals that you want to achieve, basically. Or you could say that A0 is something that results out of nothing, and A infinity is something that results in nothing. Okay, so Shashi, week 9 we are going to discuss next week, not this week. Uh, okay, so let me. Week 8, question 9. Do you mean from the current assignment? If it's a current assignment, we can't discuss it. If it is from the live session, uh, no, week 8 is the current week, right? So I think you might be confusing for. So Pranav, whether we can have two diet out sessions or not, that is unfortunately not in my hands. If you want, you can request the NPTEL team to hold one more set of doubt sessions or live sessions, and if they can get hold of one more TA, it will be great for everyone. Um, yeah, so please carry forward your request in the discussion forum or to the NPTEL team directly if you want. Okay, so let me first have a look at the last question from the previous week that was requested in the discussion forum, and then we'll see if we can discuss question 9 that you're talking about. So this was basically the SSS star method, okay? And you were asked about the horizon nodes or the initial set of clusters that from the horizon nodes that will be part of the initial set of clusters and the list of nodes that will be part of solved, okay? So unlike last week, I'm not going to solve or display the whole priority queue that we had constructed last time because that would require a lot of time consumption. I will just give a intuition. So the way we formed the initial clusters was we considered all children of the max nodes. Let me use a different ink. All children of these max nodes and the leftmost child of the min nodes. Okay. So if you follow that strategy, what are the horizon nodes that you end up with? Okay, this will not be there. Right? So here you see that you considered all children of the max node. Whenever you're considering a max node, you're considering all its children. But when you're considering a min node, you're considering only the leftmost child. Right? So these will basically be a part of your initial cluster. Okay, so these will be A, C, I, K, Q, and S. Okay, that is what is the answer given over here. The horizon nodes in the initial set of clusters found by SSS star are A, C, I, K, Q, and S. Now let's have a look at what will be the list of what are the horizon nodes that will be assigned solved status by SSS star. Okay, so let me erase all of this once more. So if you remember, when we followed all those steps to construct our priority queue and we arrived at the initial clusters through our priority queue, uh, what was the order in which the clusters were arranged in the priority queue? They were arranged uh, in a descending order from their value, right? So basically, the node having the highest value will be at the top of the priority queue, which in this case happens to be I, 52. Okay, so we'll have a priority queue like this. There will be I, 52, then there will be A, 40, then there will be C, 36. Okay, so this I'm continuing here again. After C, we will have S, 31. Then we will have K, 27. And at the end, we will have Q, 11. Okay, so this is what our parity queue would look like. Okay, yeah, if you can mute yourself, that will be great. Huh. So given this is the priority queue structure, we will take this I node into consideration. Okay, and in order to, this has already been assigned a solved status because it's now part of our initial cluster. In order to solve the parent of this node, we will look at the neighboring or sibling of this particular node, which happens to be this J node. Okay, and we see that this does not have any other sibling, so we will say that J is also solved with value 84, and because both 52 and 84 I and J have been solved, we can say that the parent of these two has also been solved, and we will assign it a value 52. Okay, and remember, this is a min node. So once this is solved, we can immediately say that its parent, which is a max node, is also solved with value 52. And as a result, this whole thing will be pruned off. Okay. Now that this max node is solved, we will look at its neighbor, which is this max node, and we will solve this subtree using SSS star recursively. Again, they will apply all the children of max node and the leftmost child of min node to find the initial clusters. Okay, so that would result in M being a part of it and O being a part of it, but I think O was not a part of it, right? Okay, anyway, let's carry forward, move ahead with the solution. And yeah, so these will have M99 and O96 as the priority queue, and then we'll try to solve M. So because M is getting solved, so we'll also say that N is solved. Okay, and once N is solved, we will assign this 98. Once this is solved, we will assign this 98. Okay, and once these two are solved, we can say that this is solved with value 52, and again, because this is a min node, this will be solved with value 52, and this subtree and this subtree will get pruned off. Okay, so apart from the initial clusters, my understanding is that the other nodes that other horizon nodes that should be part of solved would be J, M, N, and O. But I see that O is missing from this solution over here. So if that is some of the a doubt that you guys might have had, then you can either verify my solution, I might be wrong as well, and if you think that this is correct, you can raise this in the discussion forum, and if there is any correction needed, they will correct it. Okay, so was there a doubt? Okay, I guess it was by mistake, so no worries. Yeah, min, max, and SSS star values can be same. You can verify it for yourself. Okay, so this was it. Then what else? Question 9 you were talking about. Okay, for the two-player game tree, which of these could be a strategy for max? Right, the strategy for max could be game tree B and C, right? You can straight away say that game tree A and D would not be right choices in this case because we are selecting multiple nodes from max, right? So remember that SSS star method is the only one that goes the opposite way by choosing all children of max. Otherwise, usually we just choose one of the children of max. Okay, so game tree A chooses two children of max, so this is not right. Game tree D chooses three children of max, so not right. Game tree B chooses one child of max and all children of min, so this is correct. And similarly for game tree C. So B and C are the correct options. Okay, so Pranav says that the nodes pruned in alpha beta are also pruned in SSS star. So yeah, maybe that is why O is pruned off and not considered. Then in that case, the solution is correct. Okay, thanks for pointing that out, Pranav. And yeah, others can also verify it once. Um, no, A is not correct strategy for max. If you want to find a strategy for min, just replace the nodes, the max nodes with the min nodes and try to find a strategy. But that is not what is the question, what the question is asking, right? So yeah, basically B and C are the correct options for max node, which is the root node in this case. All right, so yeah, sure, I'll try uploading the Jamboard slides as well. Um, and yeah, thank you all for attending. I hope this was useful to some extent. Thank you all for also your enthusiasm and inputs during the live session. And yeah, let's meet next week.